Okay, this is moles and stoics, and we've only got one lesson left after this in this unit. In today's lesson, we are going to talk about the difference between empirical formula and molecular formula, and we're going to learn how to determine the empirical formula of a compound given its percent composition or the mass of the elements in grams. Let's begin by differentiating between empirical formula and molecular formula. The empirical formula is the most reduced formula. It's one in which the subscripts can't be reduced any further, whereas the molecular formula is actually a multiple of the empirical formula, and it represents the actual formula for the compound, and the subscripts represent an actual quantity of the atoms present. So when we look at N2O4, which is dinitrogen tetroxide, we can see that that can be reduced to, so 2 goes into 2 once and 2 goes into 4 twice. So the reduced formula would be NO2. C3H9 can be reduced to CH3. 3 goes into 3 once, and 3 goes into 9 3 times. Glucose, C6H12O6, 6 goes into 6 once, 6 goes into 12 twice, and the 6 goes into the 6 once, so CH2O. B4H10, common denominator here would be 2, so this would be B2O5. And C5H12, well, that can't be reduced any further, so this would just be C5H12. So sometimes the empirical formula and the molecular formula are one in the same. So let's look at these here and see, are there any that can be reduced? Well, CH can't be reduced, CH3 can't be reduced. If I look through C, D, E, F, and G, none of them can be reduced any further. C2H6 can be reduced. 2 goes into 2 once, and 2 goes into 6 3 times, so that can be reduced to CH3. And if I look through the rest of these, none of them can be reduced. Now, sometimes we will have to calculate the empirical formula given the percent composition. And there are rules here, but I'm going to tell you something that's a little bit easier. First of all, we always assume that we have a 100-gram sample, and if we have a 100-gram sample, that's 100%. So, percent 2 grams grams to moles divide by small times till whole. So that's a little saying that helps you remember the steps. Percent to grams, grams to mole, divide by small, times till whole. So what that means is that if I have a compound that's 46.2% mass carbon and 53.8% mass in nitrogen, that's the same thing as saying 46.2 grams and 53.8 grams. Because if I have a 100-gram sample and that's 100%, then my percent is the same as my grams. Next, we're going to convert to moles. So percent to mass, mass to moles, so grams. So how many grams of carbon did I just say I had? 46.2 grams of carbon. And remember, 1 mole equals the gram formula mass, so the gram formula mass of carbon is 12.011. So my grams will cancel. 46.2 divided by 12.011 is 3.85 moles of carbon. For nitrogen, we said that we just had 58.3 grams of nitrogen. 1 mole of nitrogen is equal to 14.0067 grams of nitrogen. Grams cancel. And when I divide, I get 3.84 moles of nitrogen. But we must have whole numbers for subscripts. So what's the next step? We did grams to moles. Now we have to divide by small. So the smaller of the two numbers of the moles is 3.84. So I divide both of these by 3.84. This is your divide by small. That's going to give you 1. And this is going to give you 1.0026, which is really 1. So what you can see is that C to N is a 1-to-1 ratio. Therefore, my empirical formula is simply Cn. Okay, determine the empirical formula from the percent composition of each of the following. So I have 24 grams of carbon and 32 grams of oxygen. Calculate its empirical formula. So remember, it was percent to mass. That was step 1, okay, or percent to grams. Step 2 is grams to moles. Step 3 is divide by small. Step 4 is times till whole. So we're starting with step 2 because we already have grams, so we're going to do grams to moles. So carbon, we have 24.0 grams of carbon, and we know that 1 mole of carbon is equal to 12.011 grams of carbon. So my grams of carbon cancel, and when I divide, I get 1.998 moles of carbon. For my oxygen, I have 32 grams of oxygen, and I know that 1 mole of oxygen is equal to 15.9994. So my grams of O cancel, and I get 2. Well, this is close enough to 2. This is 2 moles of oxygen, so this really equals 2. So 2 to 2 is the same as a 1-to-1 ratio. So my formula is CO. A compound contains 0.5 moles of carbon for each 1 mole of hydrogen. Calculate the empirical formula. So remember, it's percent to grams, grams to moles, divide by small. So I already have moles, so I'm going to divide by the smallest number of moles. So I have carbon, 0.5 moles of carbon, and I have hydrogen, 1.0 moles of hydrogen. So 0.5 is smaller. That's going to give me 1. And if I divide 1 by 0.5, I get 2. So C to H is a 1 to 2 ratio. Therefore, my formula is CH2. Okay, so now we're starting with percent. So we have to do the whole thing. So I'm going to write it over here, percent to grams, just as a focus. Then we're going to do grams to moles. Then we're going to do divide by small. So we divide by the smallest number of moles, and then if we have to, times till whole. So 14.6% carbon is the same as 14.6 grams. 85.5% 4% chlorine is the same as 85.4 grams because we're assuming it's a 100-gram sample. So 14.6 grams of carbon, 1 mole of carbon is 12.011 grams of carbon. Grams cancel. And this is going to give me 1.22 moles of carbon. And then I've got 85.4 grams of chlorine. And I know that 1 mole of chlorine has a mass of 35.453 grams of chlorine. I'm getting this from the periodic table. Grams cancel, and I get 2.41 moles of chlorine. So I've done percent to grams, I've done grams to moles. Now I've got to divide by small. So my smallest one here is 1.22, which is going to give me 1, and 1.22, which is going to give me 1.97, which is approximately 2. So my C to Cl is a 1 to 2 ratio. So CCl2 is my empirical formula. Okay, let's try another one. Again, this is the same as 32.8 grams of chromium and 67.2 grams of chlorine. So I've got grams, so now I need to do grams to moles. So we'll start with chromium, 32.8 grams of chromium, and we know that 1 mole of chromium has a gram formula mass of 51.9961 grams, and that's going to give me 0.6308 moles of chromium. Then I'm going to do my chlorine, which is 67.2 grams, and we know that 1 mole of chlorine, we just did this, has a mass of 35.453 grams. Grams of chlorine cancel, and I get 1.895 moles of chlorine. I need to divide by the smallest one. 0.6308 is going to give me 1. 0.6308, when I divide that through, is going to give me 3. So my CR to my CL is a 1 to 3 ratio. So CrCl3 is my empirical formula. And I believe we have one more, and that's it for this lesson. We'll finish with 67.1% zinc, which is the same as 67.1 grams. And here they tell us that the rest is oxygen. Well, if you know that everything's based on a 100-gram sample, 100 minus 67.1 equals 33.9, I believe. 32.9. So that would be for oxygen, 32.9 grams of oxygen. So let's start with our zinc. Zinc is 67.1 grams of Zn, and we know that 1 mole of zinc has a gram formula mass of 65.38 grams. Grams cancel, and that gives us 1.026 moles of zinc. And then we have oxygen, which is 32.9 grams of O. We know that 1 mole of O has a mass of 15.9994, and that's going to give me 2.056 moles of O. Divide by the smallest one. That gives me 1, and this gives me 2. So my Zn to O is a 1 to 2 ratio. So Zn O2 is my empirical formula. Okay, and that's it for this lesson. This is determining the empirical formula given either the percent composition or the grams.